Hi everyone, so in this part we're going to be looking at properties of acids and bases. So for the NOS section of this unit, it talks about how the experiments have been carried out to investigate about the properties of acids and bases to be able to either support or refute theories that we had about acids and bases. So there's going to be reactions that will be investigated to try to see if there's any patterns between reactions. Now, bases can be metal oxides, metal hydroxides. Ammonia is a base. You have carbonates. Normally, all carbonates are insoluble except group 1 carbonates and ammonium carbonate. So sodium carbonate, potassium carbonate. If you still remember, carbonate is a radical, CO3 valency 2, so CO3 2 minus. So you'll have sodium carbonate, NaCO3, Na2CO3, and potassium carbonate, K2CO3. Hydrogen carbonate is HCO3, has valency 1, so HCO3 minus. Sodium hydrogen carbonate, NaHCO3, potassium hydrogen carbonate, KHCO3. Okay, now alkali are soluble bases, and when dissolved in water they release OH minus ions. So anything that produces OH minus ions in solution is an alkali. For example, here this is going to dissociate, it's a metal oxide, so K plus plus OH minus. Balance the equation as such. Ammonia is a weak base, so I'm going to use reversible arrow. This gives me NH4 plus and OH minus. Carbonate in water, so this is going to give me HCO3 minus and OH minus. Now note, carbonic acid, H2CO3, that's an acid, okay, it gives H plus. But here carbonate, this is acting as a base, as an alkali, because it is accepting H plus. Hydrogen carbonate as well, hydrogen carbonate acts as a base, so it's going to, so we need to add water here. So this is going to accept an H plus, so H2CO3 plus OH minus. So because you have formation of OH minus, you have, these are all bases. Now if we look at properties of acids and bases, difference in taste, pH, color of litmus, color of phenolphthalein, color of methyl range that you need to know, and these are all indicators. Now for the pH of acids, the weaker the acid, the higher the pH, the stronger the acid, the lower the pH value. And for bases, the stronger the base, the higher the pH. For example, pH 14 is for a very strong base, NaOH, and weak bases will have low pH value. Now, a salt is an ionic compound, and it's formed when you have the hydrogen of an acid which is replaced by a metal or another positive ion. For example, if you have the acid HCl and the base NaOH, so when the H plus of the acid is replaced by the positive ion, so you have NaCl, so Na is from the base and Cl is from the acid. Similarly, you could have ammonium sulfate. Now ammonium sulfate, so this is from an ammonium salt, so you have NH4 plus positive ion which is from an ammonium salt. Sulfate, this is from sulfuric acid. So when the H plus, when the hydrogen of the acid is replaced by a positive ion. Reactions of acids with reactive metal. So any metal which is above hydrogen in the reactivity series is reactive. So I hope you remember your reactivity series. So everything which is above hydrogen, so these are reactive, therefore they will produce salt and hydrogen. But be careful, lead usually is unreactive in acid because lead salts are insoluble. So as soon as, let's say you have a piece of lead which is put in a solution in an acid, what will happen is that the reaction will start, but the layer of lead salt which is formed is insoluble, and this insoluble layer will prevent the lead from reacting any further. So verify your equations now. So you have salt plus hydrogen, salt plus hydrogen. Ethanoic acid is CH3COOH, and when you have the salt which is formed, this is the ethanoate ion, so you will have sodium ethanoate. So this is the convention that we use to write the salt sodium ethanoate. We put the ethanoate first and then the sodium second. So verify your equation that include the state symbols. Acid plus base, salt and water. This is called the neutralization reaction, and verify your equations. So here you go, your equations. Now all reactions of acids and bases are called neutralization and can be represented by a common ionic equation. If you still remember your IGCSE, it's H plus OH minus giving H2O. So any neutralization reaction can be represented by this. So all these three will be represented by the same neutralization reaction. But of course, this concerns when the acid and the base are both in aqueous state. So for example, let's see how we get this ionic equation. Let's say we have HCl plus NaOH giving NaCl plus H2O, and so aqueous and liquid. If you still remember how to make ionic equations, aqueous split, solid liquid gases do not split. So HCl consists of H plus and Cl minus. NaOH consists of Na plus and OH minus. NaCl consists of Na plus and Cl minus. H2O, because it is in the liquid state, will not split. Everything which is the same on both sides will cancel out. So you end up with H plus OH minus giving H2O. And this is the same for all acid bases reaction, whether the acid is diabasic, tribasic or monobasic. Now, for neutralization of a strong acid and a strong base, the energy liberated during neutralization is about 57 kilojoules per mole, and this is because the reaction that is happening is the same. So the fact that we're cancelling out these ions, these are spectator ions, so we could say that they don't really take part in the reaction. And so bee stings are acidic and they are treated using alkali such as sodium hydrogen carbonate. Wasp stings are alkaline and they are treated with weak acids such as vinegar. Now, acid and carbonate, acid plus metal carbonate gives salt plus water plus carbon dioxide. Check your equations for these. So verify your equations. So you see sodium carbonate is aqueous, but calcium carbonate we're considering it as insoluble, so partially soluble, so insoluble. Sodium hydrogen carbonate, aqueous. All sodium salts are soluble. If it is soluble, it is in the aqueous state. Now, for the ionic equation that represent these reactions, well, there's actually no need for you to do for every single reaction, but we're just going to do one of them. So let's do with hydrochloric acid and sulfuric acid and sodium carbonate. So still the same rule applies. Everything which is aqueous will split. Gas and solid liquid gas will not split. So like you see here, aqueous, so it splits into two. Aqueous splits into two. Aqueous splits into two. Gas does not split. Liquid does not split. So we'll cancel out everything that is similar on both sides. So H plus, SO4 minus, Na plus will cancel out. So what is left is 2H plus CO3 minus to give CO2 and H2O. So if you do Ionic equation for reaction of acid carbonate reaction where the carbonate is soluble in water, you should get this every time. Now write an equation for this reaction between baking soda and vinegar. Check the equation. Now passing carbon dioxide through lime water gives a cloudy suspension of calcium carbonate. So this is lime water in the presence of carbon dioxide gives you an insoluble precipitate of carbonate. Indicators, they have different colors in different pH values, and indicators are obtained from natural substances. And there's a list of indicators and the pH at which they change color in the data booklet. Now, acid-base titration. So it's a reaction between an acid and a base until the equivalence point is reached. So this is what we know as the end point. And a good indicator is one that gives a sharp color change at the end point. Now sometimes some reactions do not require an indicator. For example, when you're titrating with potassium permanganate, there is no indicator required because the color of the potassium permanganate will change from colorless, from purple to colorless. You can read the uses of acids in our daily life and verify the answers for the checkpoint. So verify your answers. And for the last question, I'd say C acids react with reactive metals to produce salt and hydrogen gas.